Okay, so again, just because it's a piecewise function, we have a slightly just different approach, right? We need to make sure that these left and right sides agree with each other. And we're focusing on these one-sided limits to help us see that. So again, I want to point out x is approaching 3 matches the 3's that you see up here. We've got one function on the right. I think that's fine. And one function, I said that backwards, on the left and on the right. So let's look at those. So let's look at the left. That's the limit as x approaches 3 from the left of g of x, which for us, the left-hand function is x squared minus 4. So this will be a closed dot when we look at it. Again, it doesn't solidify the limit overall, maybe the left or the right on its own, but and so this is going to be using direct substitution, 3 squared minus 4. And I just want to clarify, this is sitting where an exponent sits. It does not change the sign of the 3. It's just telling me the side that we're going in from. This becomes 9 minus 4, which is 5. So the left limit, 3 from the left-hand side of g of x is equal to 5. Now, I want to pair that with my right side limit. Okay, we're looking at the limit x approaches 3 from the right of g of x, which is the limit x approaches 3 from the right of x plus 3. Again, it's not technically defined there, but that's not the point. We're looking for a limit, not a function value. So using direct substitution, this gives us 3 plus 3, which is 6. So that limit, that right-sided limit, x approaches 3 from the right, g of x is equal to 6. Now, you can already see there's a problem here, right? There's a disconnect between these two. If we were to graph these, again, I want to be conscious of this value of c, x is equal to c, which in our case is 3. Okay, so what's happening with each of these? Well, on the left-hand side, we have something quadratic, right? This is a parabola. Blue. This is a parabola. It opens up and it's gone down 4 units, right? So if we went down 1, 2, 3, 4, that's actually where your vertex would be, right? And so you'd have a point here, here. And so we are, we actually see, and I can make this easier to read on my graph. At 3, we're going to 5, and that's open. So this will continue to here, okay? That is your left. I think I used my colors backwards from last time. Sorry about that. Okay, on the right-hand side, this is just a straight line. We start at 1, 2, 3. There's your first point, and then our slope is 1 and 1. So here, 1 and 1 and 1 and 1. So this straight line, mostly straight line, looks a little more like that, assuming, again, I can draw a straight line, which it appears I cannot. And this is your right side. Okay, so there is a disconnect, and you can see that where x is equal to 3, there's a disconnect right here. So these two, these disagree with each other, which means that the actual limit as x approaches 3 of g of x does not exist because they disagree.